The first program which we will discuss in this tutorial is called Sniffer.c. This is a very simple Sniffer program which binds to an interface and receives packets from that and displays the packet in hex on the screen. So let's quickly first look at the program flow and then discuss the individual functions in more detail. So this is the main function, and first of all we go ahead and create a socket. Once we've created the socket, we bind that socket to an interface, a choice which we provide to the user. After that, we also take in the number of packets to sniff from the user. That's also an input. And then we go ahead and start sniffing and print the packet in hex. This is the main loop where that happens, and whenever a packet is successfully received, we print that packet onto the screen. Let's first look at how this program actually executes. So let's compile it and then let's run it. Before running, what I'd like to point out is the ifconfig command. So as we are seeing that this is the Ethernet interface ETH0 and this is the loopback interface. Loopback interface is an internal interface which the kernel uses. We are more interested in the ETH0 interface through which we are connected to the rest of the LAN. We can also see that this is our MAC address and this is our IP address. One thing which you are noting is this statement up broadcast running multicast. So what this means that this interface is up receiving both unicast, broadcast and multicast packets. So as we had discussed earlier, we want to put this interface onto promiscuous mode so that it can receive all packets. For that, the command is simple: ifconfig eth0 promisc. Now if we run the ifconfig command, you will notice that that line has changed from if broadcast running multicast to if broadcast promisc multicast. It actually means it's also in promiscuous mode. These are nothing but flags. Okay. Once the interface has been set into promiscuous mode, now it can receive packets from all hosts on the connected LAN. Now let's run our compiled sniffer code. ETH0 is an input and the number of packets you want to sniff. Sorry. So as we can see that a packet has been sniffed and the packet has been dumped in hex format. Packet starts, packet ends, and we have the hex equivalent of the packet in between. Now let's look at the code a little bit more deeply. Raw is basically the socket descriptor for the raw socket. Packet underscore buffer is what is going to contain the packets which we receive from the interface. Len you would get to know a little later. Packets to sniff is basically the input which the user gives as to how many packets to sniff, display on the screen, and then exit. Sock addr underscore ll, a packet info, is nothing but some of the information which the kernel gives back to us about the packet which we have sniffed. We look into this structure a little later. Packet info size is nothing but Let's look at the main function now. raw is basically the socket descriptor for the raw socket. Packet underscore buffer is the buffer which is going to contain the packets which is sent to us from that interface. Packets to sniff is an input which the user is going to give us regarding the number of packets to sniff. Packet underscore info is a structure of type sock_addr underscore ll which is going to contain some information about the packet which we have currently sniffed from the network. This the kernel would basically fill up and give it to us. Packet info size is nothing but the size of that sock_addr underscore ll structure. We'll look at the structure a little later. Now after that we call the create raw socket function. Now what this function is going to do, let's basically go to the function itself. So it simply creates a raw socket and takes input of the protocol we want to sniff. Right, we already discussed how to create a raw socket. It's by calling socket with pf underscore packet sock underscore raw and the protocol we want to sniff converted into network byte order. So as we clearly remember that ETH underscore P underscore IP is the protocol type for IP networks which we are interested in sniffing. So this call creates a raw socket and which is stored in raw. Then we go ahead and bind this socket to an interface on which we want to sniff. So argv1 is nothing but the interface ETH0 or another any such equivalent which the user is going to give us. Raw is the socket which we just created. ETHP IP is the protocol which we are interested in once again. So let's go to the bind raw socket function and have a look at what it does. Once again we see the sock_addr underscore ll structure and another structure called ifreq. Now let's quickly look at how we can find out about all these structures. One way is of course to go ahead and see the include files and open up the include file itself, net underscore if.h. So let's open up a new terminal and just open up that file, user include . So now we can see that this is the ifreq structure, right? But the point is, this is a very tough way of finding out which structure is where, what are the members of that structure, etc. So there's an easier way to do it. There's a utility called cscope. It should be installed on most systems by default. If not, you can download it from the internet. So this is actually for code browsing, and I think most of you might be familiar. So what we have to do is just let's say have this file sniffer.c